Have you ever looked at a picture and felt like that picture is alive because it starts to move? You actually know the picture is still, but your eyes say otherwise? Whenever I see a picture moving or rotating, I feel like I'm in mind games and the leading role is me and my brain. My name is Durutgan and today we are here to discuss these mind games. Optical illusions don't trick the eye, nor fool the brain, nor reveal that our brain sucks, but they are fascinating. Now, let's take a look at these dazzling illusions. Our first illusion is called spinning ballerina illusion. Now watch her spinning gracefully. Can you tell in which direction is she spinning? Left, right, or both? The spinning dancer illusion is an example of a bistable motion illusion. It has been suggested that the direction of perceived movement may depend on which hemisphere of the brain is more active. If the dancer is seen as regularly switching the direction of movement, both hemispheres are equally active. This could be explained by the fact that when looking to the left, the dancer will be perceived in your right visual field, which is connected to the left hemisphere of the brain. Conversely, when looking to the right, the dancer will be perceived in your left visual field, which is connected to the right hemisphere of the brain. Now, let's move on to our second illusion. This mind-blowing optical illusion is called the checker square illusion. The illusion is comprised of a checkerboard with squares that appears to be different shades. The illusion asks you to focus on the shades of the two squares that are marked with the letters, then asks you to decide which square is darker. At the onset of the illusion for square marked A, clearly appears to be the darker square, but when a black background is put behind the square, it is revealed that the two squares are actually the same shade. The green image creates a shadow effect which fools us into believing that one of the squares is darker, but in fact they are the same shade. The third illusion is called the Hermit illusion. This is a classic example of what vision scientists call simultaneous lightness contrast illusion. While there are only black blocks and white spaces in the grid, the high contrast black and white areas fool the eyes into perceiving a gray circle at each intersection. This illusion was discovered in 1870 by a physiologist and named after him. The illusion demonstrates a phenomenon known as lateral inhibition. All of the dots are white. We only perceive them to be changing colors. So, in actuality, we are seeing something that isn't even there. There are no gray dots. The illusion results from retinal cells adjusting the brightness of an image by adjusting the intensity of the light signal in many small areas, which allows you to see both bright and dark details in the same image. Due to inhibitory processes in the retinal ganglion cells, the neurons that transmit signals from the eye to the brain. To each cell, there corresponds a small region of the retina, called the receptive field, where photoreceptive rods and cones can trigger an electrical response in that cell. The receptive fields of adjacent ganglion cells may overlap. The next optical illusion asks you to look at two tables. One is horizontal and one is vertical. Then decide which table can be moved easier through a narrow door. You probably think the answer should definitely be the vertical table. However, in reality, both tables are the same size. This illusion was first presented by an American physiologist, Roger Shepard, and named Shepard's illusion after him. Our minds are making 3D interpretation out of 2D pictures. Our perception is interfering with our reality in this illusion. When the top of the first table is removed and placed on the second table, we can see that in fact they are the same size. Nothing appears abnormal about this Rubik's Cube until you realize it's a two-dimensional image. They say seeing is believing, but can you really trust what you see? This illusion is created with a distorted perspective of an image, requires to be viewed at a specific vantage point to create a 3D effect. This method is used in 3D sidewalk art. Speaking of sidewalk art, I took this picture in Wilhelmshaven, Germany. It is tricky, right? Due to the arrangement of the image, the effect of colors, the impact of the light source or other variables, many misleading visual effects can be seen because our minds manipulates us to see so. Speaking of manipulation, I want to show you something. You can somehow manipulate the fluidics to create optical illusions by photolithography or microfluidic channels. Now, I'm gonna show you a project called Drawing Hands. They use two microfluidic channels as lines. While a dyed fluid fills the channels, the single lines are literally drawn. As the channel fills and the hands are drawn, each hand turns out to be drawing the other. In paper is static, this is dynamic, so the fluid continuously flows during the drawing process. As the channels are filled and refilled, the image is erased and redrawn. This relies on the theory of fluid flow through the channels. Isn't this amazing? It's an endless microfluidic illusion. As if optical illusions aren't enough to be fascinating, they can also be done with microfluidics. If these illusions have already impressed you, are you ready to take a look at 3D printed illusions? I assume that you say yes. 3D printing or additive manufacturing is a simple process of making three-dimensional solid objects from a digital file. It is magical, right? Now I want to show you something which is also 3D printed. This object was printed by Zach King, who are indicated in my references below. In this 3D printed illusion, it looks like the marble is going upstairs, but it's actually going down. Our next illusion is one of my favorites. You've probably heard the Penrose Triangle before. It's also known as the impossible disorienting. It's an impossible triangle made possible by how you look at the angle. It feels like the left side is extending away and the right side is leaning towards you. However, they both seem to be on the same plane. Only an optical illusion makes it seemingly possible to see on the human eye. Here, you can see the 3D printed triangle. When you line it up correctly, it looks terrific. So far, I've talked about the interesting ways to make an optical illusion, including microfluidics and 3D printing. It's even possible to create 3D illusion patterns with CNC. Optical illusions can be fun and fascinating, but these mind games can also inflict the reality. As Jenna Marble said, there is no cure for ugly, but you can make yourself into a human optical illusion. Which illusion amazed you the most? Please share on the comments below. Don't forget, if you're into this topic, please check out my references. If you want more videos like this, please don't forget to subscribe. Have a great day!